Good morning and Assalamualaikum. My name is Hydrodynamics binti Nasaruddin. My mention number is 06DKA24F1069. Today I will be presenting about fundamental principle and application of hydrodynamics in civil engineering. This topic is very important because as future civil technicians, we must understand how water system and fluid mechanics works in order to design safe and efficiency infrastructure. First, I will introduce what is hydrodynamic. Hydrodynamic is a branch of fluid mechanics that studies the motion of fluid and the force acting on them. The main purpose is to understand how fluid move and how they interact with different structures. In civil engineering, this knowledge is very practical because it helps us to design water distribution system, drainage, irrigation canals, even dams. So hydrodynamic is not only about theory in the classroom, it is directly applied in real engineering projects. Now I will explain about fluid properties. There are four main fluid properties that are very important in hydrodynamics. First is viscosity, second density, third is pressure, and the last velocity. Firstly, viscosity refers to the resistance of a fluid to flow. A fluid with high viscosity, such as honey, flows very slowly, while a fluid with low viscosity, such as water, flows easily. In civil engineering, viscosity is important because it affects pipe flow design and the energy required by pumping system. Secondly, density is the mass of a fluid per unit volume. For example, oil floats on water because it has a lower density. This property is important in buoyancy, fluid pressure, and structural design. Thirdly, pressure is the force exerted by a fluid per unit area. Pressure acts equally in all directions and it increases with depth. Following the equation, P equals rho GH. A clear example is the high pressure experienced deep in the ocean. In civil engineering, we must consider pressure when designing tank, dams, and pipeline. Finally, velocity is the speed and direction of fluid flow. Velocity shows how fast and in which direction a fluid particle is moving. It is closely related to the continuity equation A1 V1 equal to A2 V2, which we will discuss later. Velocity is applied in the design of drainage system and irrigation canals. Next, we're gonna talk about type of flow. There are several types of flow that we need to understand. First, in steady flow, the velocity, pressure, and density at any point remain constant over time. This means the flow is stable. For uniform flow, the velocity is the same at every point along the flow path. Meanwhile, in non-uniform flow, the velocity changes from one point to another. Understand this type of flow is important because they affect whether a system operates smoothly and face turbulence and energy loss. Now we move on to type of flow in Renault experiment. In 1083, Osborne Renault carried out a famous experiment to study fluid flow. He used a glass tube filled with water and injected dye to make the flow visible. From his experiment, he showed that flow can be laminar, transitional, or turbulent. For laminar flow occurs at a Renault number below 2000. It is smooth, orderly, and occurs at low velocity. For transitional flow, occur when the Reynolds number is between 2000 and 40,000. It is unstable, a mix between laminar and turbulent. For turbulent flow, all happen when the Reynolds number is above 4,000. It is chaotic, regular, and full of swirl and eddies. This experiment is very important because it introduced the concept of the Reynolds number, which engineers still use today to predict whether a flow will be laminar or turbulent. For governing equation, there are two main governing equations in hydrodynamics. The first is continuity equation. The second is Bernoulli principle. For the first is the continuity equation, which states that mass cannot be created or destroyed in a fluid system. The formula is A1V1 equal to A2V2. This means when the cross-sectional area of a pipe becomes smaller, the velocity must increase, and when the area becomes larger, the velocity must decrease. This equation is widely used in pipe system, duct, and river analysis. The second is Bernoulli principle. It states that when the speed of fluid increases, the pressure or potential energy decreases. The formula is P plus 1 per 2 rho V2 plus rho GH equal to constant. A common example is the lift force on a airplane wing. Faster air on top creates lower pressure, which helps the plane lift. In civil engineering, Bernoulli principle is used to understand pressure drop in water system and to design pumping system more efficiency. Now, let's look at the case study involving water distribution system in Malaysia. Most of Malaysia's water supplies come from surface water sources. It is delivered to consumers through the network of pipes, storage tanks, and pumps. However, there are some problems. In hillside houses, water pressure is very low. Many of the pipes are old and narrow, which cause high energy loss and more friction. By using hydrodynamic principle, we can analyze this. The continuity equation tells us that the flow going in must equal the flow going out. Bernoulli principle explains that pressure drop as water flow to higher elevation and when pipes are low. To solve this problem, we can install booster pump to increase pressure. We can replace old narrow pipe with larger and smoother one to reduce friction, and we can also add elevated storage tanks to stabilize water supply. To confirm this case study, we carry out site observation. The observations show that residents in hillside houses often complain about weak water supply, especially during peak hour. When we measured the water pressure, it was below 1.5 bar, which is not enough for normal household usage. We also noticed that water distribution was uneven. Houses in lowland area receive stronger water supply, while houses uphill receive every weak pressure. This site finding clearly support the analysis in the case study. They prove that hydrodynamic principles like Bernoulli equation, continuity, and heat loss directly explain what happened in real water distribution system. Now, the reflection from hydrodynamic and my growth. From this study, I get a lot of valuable learning. In terms of knowledge, I now understand better how fluid flow, pressure, and energy loss work in real systems. In terms of skill, I can apply hydrodynamic principles to analyze and improve water system. In terms of design making, I will feel more confident in choosing solution for suitable water management. Lastly, in conclusion, hydrodynamics is the study of how fluid move and the force acting on them. By applying principles such as the continuity equation, Bernoulli principle, and Reynolds number, engineer can analyze and solve real problems in water distribution, pipe system, drainage design, and many more. This knowledge is very important for civil engineering because it helps us make informed decisions, design efficient system, and support sustainable water management for the community. That's all. Thank you for your attention.